So before we talk about the quotient rule, let's revisit the product rule. So we're just going to write product rule over here. Okay. So the product rule, h of x, or h prime of x rather, is equal to what? The derivative of first. It's g prime of x. Okay, so the derivative of the first times the second plus the first times the derivative of the second, right? Okay, so and remember, you don't want to memorize it as f and g. It's the derivative of the first times the second plus the derivative. I guess we should have had of f if h of x is equal to f of x times g of x. So the derivative of the first times the second plus the first times the derivative of the second. Notice here, you're only in each little set, you only take the derivative of one of them. So would it really matter in the end if this was g times f prime? No. Would it matter if these two came after this one? No. Okay, but the reason that we're doing it this way, and the reason Miss Bruce was like, okay, this is different for me, this is different than from what I'm teaching, because we had a whole discussion before y'all get in here about the fact that some people teach it differently. And I said to her, I know Ackerman doesn't teach it the way she does. I said, but I don't know why. I don't know if he told me why. And she said, well, I've been to a training where a lady did it one way, then the next training I went to, she did it a different way. So we called him in here and we were like, why do you do it differently? Like, there has to be a reason. It's not just because, whatever. I mean, there's not one hard and fast rule as long as it means the same thing. And he said, well, I do it this way because it ties directly to quotient rule. So if you know this, you can get quotient rule down pretty easily, because this is what the quotient rule looks like. So it's a quotient because we're dividing. You've got f over g of x, right? So instead of the first and the second, you have the top and the bottom, but we usually read left to right and top to bottom, right? So the derivative of the top times the bottom, and then since it's quotient and not product, it's minus then the top times the derivative of the bottom. Do you see how this is in the exact same order? But this is plus and this is minus. It's the same thing. But here, order matters big time. I mean, yes, I could switch these two around, but could I have this come first and then it say minus the other one? That's a big fat no. So if you're consistent in how you do it, it just kind of helps it a little bit. But do know that, and we looked up some different sources, like Delta Math does it this way. I think Khan Academy does it this way, but you could see it other times where if somebody's giving you the rule, they have it a little bit different. Doesn't mean that they're wrong or you're wrong. It's just a different, you just have to know mathematically if it's the same or not, and you'll be fine. Then the denominator is just the bottom squared. No derivatives in the bottom. Okay. So the derivative of the top times the bottom minus the top times the derivative of the bottom. Just like derivative of the first times the second plus the first times the derivative of the second. We got it? Easy enough? Okay. So let's try this. So we have, this is y, so we want dy dx. So we're going to start with the derivative of what? Of the top, right? So the derivative of the top, or the first one, you can think of it as first and second. What's the derivative of sine? Cosine. So I have cosine x times the bottom, which is x cubed, minus the top, which is sine x, times the derivative of the bottom, which is what? 3x squared. All over x cubed squared. We okay with that? So then that means that dy dx equals, so to kind of clean this up, we'll have x cubed cosine x minus 3x squared sine x over x to the what? 6th. Do I have a GCF in the numerator? Yes. What is it? x squared. So I can factor out an x squared. That leaves me with x times the cosine of x minus 3 times the sine of x all over x to the 6th. Can I simplify that fraction? Yes, I can. So I can cancel those out with 2 of those. That would be a 4 down here. And so then that equals x times the cosine of x minus 3 times the sine of x over x to the 4th. And that is dy dx. Okay. And we're going to start labeling our answers with, I'm trying to pick a good color that I could be consistent with, probably with red. Either a safe stop, which means it's your free response answer, that's your safe stop. If I substitute all this in right here, did I show that I understand the derivative? So this would be my safe stop answer. If this was free response, that's a safe stop. If I keep going and I get to here, this is your multiple choice answer. That's why we have to be able to do it. Yes, you can stop here because I've substituted everything in and I've taken the derivative, but then I could move on. Okay, make sense between the two? All right, good deal. All right, so I want you to set up this next one, f prime of x. SpongeBob shoes on today. Squeaky. You start with the derivative of the top. What's the derivative of f? What's the derivative of the numerator? No. The derivative of 5 is 0. Then so yes, this gives you 0, but what's this derivative? Negative 1. Good catch on that. Why do you have 0? Okay. Okay. So I'll tell you what I've seen that's good, what I've seen that's not so good. So we take the derivative of the top. The derivative of 5 is 0, but the derivative of negative x is negative 1. Then I have to multiply that by the denominator. That's x squared plus 2. So it looks like everybody remembered their parentheses, which is good. Minus, so that was the derivative of the top times the bottom. So now it's minus the top, 5 minus x, those parentheses totally matter, times the derivative of the bottom, which is what? 2x. All over x squared plus 2 squared. Okay, so here's the thing on simplifying. The numerator, now first of all, this is a safe stop. Free response, if you don't have to go any farther, you could stop there. But if we do need to clean it up, we start with the numerator. We may not have to clean up the denominator. We'll see. I'm going to leave that. So this is going to give me negative x squared minus 2. And then this 2x times 5 is 10, so that'll be a negative 10x. And then negative 2x squared, and then a negative of that, so then plus 2x squared. And I'm going to leave this x squared plus 2 squared down there. So then to clean it up a little bit more, I'm going to have x squared minus 10x minus 2 over x squared plus 2 squared. So one of the reasons you clean it up is to see then, could I factor to maybe simplify and cancel out with the denominator? Is there going to be anything in this where I could cancel anything out? No. So then there's no need to do this, which is good, because some of you would put x to the fourth plus 4, and then I would have to disown you, right? You do not get to square, you just distribute the square. That's not okay. If you did multiply out the denominator, that's fine. But again, you want to kind of double check your multiple choice answers and see what's being expected of you. But then this would be a multiple choice kind of version of that. Okay. Yes, it could possibly be that one. Absolutely. Yes, it could be. That's why you just kind of, so doing it is not wrong. But don't do it until you've looked at your answer choices, because if none of them have that, then you might as well not try, do something weird or waste your time. We good? All right, y'all do whatever, there's not number. The next one, all on your own. Keep going. Okay, so even if you were to do everything 100% right moving forward, you would get docked on this because you need that there. Does that make sense? So then if you, let's say you did distribute, but you didn't put it there, you say that equals and you actually distribute, like maybe you were intending to do, then they're not actually equal. You get docked for that. Does that make sense? Okay. So y'all pause where you are for just a second and look at what I have. Is what I have correctly written at this point? No, what am I missing? Parentheses. Okay, so as a teacher, this is what I hear a lot. Yeah, but I'm going to distribute, and I'm going to do this and that, and you know what I meant, that sort of thing. So let's say that you do know that you're supposed to distribute, and you actually distribute here. So if I distribute this x squared here, I'm going to get 9x to the fourth plus 8x cubed, right? And then I would get minus 6x to the fourth, then minus 8x cubed plus 10x. Is that right? Okay. So now, am I correct here? Yes. Oh, here. And then down here I get x to the fourth. But I'm not correct here, right? So I want you to think about it. Is what I'm saying true? Are these two things equal? No. What I intended and what I have here are equal. But this does not equal this, because according to this, I should have just multiplied these and these, right? So even though I did this step correctly, I didn't write this, but I knew what I wanted to do, you will get what's called a linkage error. These two things are not equal. So it doesn't make any sense, right? So your work all throughout is important too. These little parentheses right here have to be there from the very beginning. Not just so that you do it correctly, but so that you say what you're trying to say. Does that make sense to you? Okay. Just kind of a little point I wanted to make there. And that's what a linkage error means, is that these two things aren't actually equal. All right, so now if we clean that up, we get, what is it, 3x to the 4th plus 10x over x to the 4th. And so then I can factor out an x, right? And I get 3x cubed plus 10 over x to the 4th. So that means I get 3x cubed plus 10 over x cubed, and that is g prime of x. All right, so I should have left a little room over on the side or something, and I didn't, but there's another way to do this whole thing, okay, without doing all of that. Doesn't work on all of them, but check this out. If I had taken this g of x, and I'm not taking the derivative yet, I'm just going to change g of x to 3x cubed over x squared plus 4x squared over x squared minus 5 over x squared. Is that the same thing as what I have up there? It's the same thing, right? So still haven't taken the derivative yet. I'm still working with g. That makes this 3x plus 4 minus 5 times x to the negative 2 power. So now, when I take the derivative, the g prime of x is equal to what? Oh, wait. Did I do that wrong? What did I do? I did something wrong somewhere. That's right. Oh, I know what I'm doing. Okay, I'm sorry. So I have, I know where my brain is going. I was like, wait. Okay. So this is just 3. The derivative of 3x is 3. The derivative of 4 is 0. Then I get positive 10x to the negative 3 power, right? So then that makes this, which would be a fine answer in itself on the next step, 3 plus 10 over x cubed. Then to get a common denominator, I'd have 3x cubed plus 10 over x cubed. So it's the same thing, but it's the power rule instead of the quotient rule. Works the same either way. Okay? And it's not, you can't turn everything into the power rule. But we did on that one. Okay, what questions you got? We good on those? All right, so flip it over. So it says, if you have a quotient in which the numerator is a constant, instead of easier, we're going to say it is more efficient. To rewrite it as something with a negative exponent. So I'm going to rewrite y as 9/5 times x to the negative 2. Notice when I took x out of the denominator, I did not take 5 out of the denominator. Don't go doing really weird stuff, okay? So then I can take the derivative, using my power rule. It's going to be negative 18/5 times x to the negative 3, which is the same as negative 18 over 5x cubed. Okay. So let's look at that using the quotient rule. dy dx. I start with the derivative of the first one, which is 0, times the second one, which is 5x squared, minus the first one times the derivative of the second one, all over the denominator squared. So what's 0 times 5x squared? 0. So I really just have negative 90x over 25x to the 4th. So dy dx, when I simplify that, that becomes 3 down there. And then they're both divisible by 5. Guess what 90 divided by 5 is? negative 18 over 5x cubed. You kind of avoid bigger numbers too. So it's fine to do it either way. There's nothing wrong with it. It's just that it's, different, more efficient. Anybody know what time we get out of here? I forgot to look. God, Devin. Normal words. 12:15. Nice try. Okay. All right. So we can use the quotient rule to derive. Here we're going to derive some of the trig functions that I told you what the derivatives were, and I told you I'll show you later. Here we go. So if we want to take the derivative of tangent, how can I make tangent into a quotient? Well, sine is what over what? Yes. What did I say? Sine? I said sine, didn't I? Tangent is sine over cosine. Okay. So the derivative of tangent is the same as dx, I love the enthusiasm, of sine x over cosine x. Right? I just changed tangent to sine over cosine. It's something we should remember from pre-cal. Yeah. Okay. Yeah. We got this. I got it. Okay, so we're going to start with, when we actually take the derivative, we take the derivative of the top, which is what? Cosine. Okay, so it's cosine x times the bottom, but it's just the bottom itself, which is just cosine x. You're right. I know you're getting ahead of yourself because you're excited. Okay, minus, then I have the regular numerator, right? Sine x times negative sine x all over cosine x squared. Everybody agree with that so far? Okay. So in the numerator, when I clean it up, cosine times cosine is cosine squared x. Negative sine times negative sine is a positive sine squared x. And then cosine x squared is cosine squared x. We didn't have a derivative that looked like that. What else can we do here to simplify? What looks familiar? What is this? It's a thing. It's the Pythagorean identity. Remember, cosine is your x, sine is your, don't you shake your head, no. Cosine, it's fine. Cosine is the x, sine is the y, right? That's your x squared plus y squared equals r squared, and your r is 1. So this is 1 over cosine squared x. Oh, see why I tortured you with all this? But here's the basic one. But the Pythagorean identities, those were basic. At least this one we should know by now. I mean, that you got to know. If you don't remember it, you got to know it now. What is the reciprocal of cosine? Secant. So this is secant squared x. That is the derivative of tangent. Well, no. Well, the same answer is what? No, this is the answer, ding dong. I'm putting what it is. So, but you did all that to give you what I already gave you the other day, but I wanted you to see where it came from and why, and it wasn't just just because she said so. So down here, the derivative of cotangent and cosecant can be derived in the same way, but the derivative of tangent is secant squared x. Okay. Now we're going to derive the derivative of the derivative of, I know, make myself laugh. You don't even get it. It's okay. Secant. So what secant is the reciprocal of what? Cosine. So I'm going to have well, it's the reciprocal of cosine. It equals 1 over cosine. So yes, you're right. So dx of 1 over cosine. Okay. We good with that? So now I'm going to take the derivative, okay, and we're going to use the quotient rule. So I take the derivative of the numerator, which is 0, times the denominator, which is cosine x, minus the numerator, which is 1, times the derivative of the denominator, which is what? Negative sine x. Okay, we agree with that? So then I get, and then the denominator squared. So this part is 0. Negative 1 times negative sign is just sine x over cosine squared x. What do you think we could do with that to get it to something we could simplify? How do I get tangent out? Is this whole thing just become tangent? No. I have an extra cosine in there, right? So this becomes, I can make that into sine x over cosine x because we recognize that that's tangent, right? Times 1 over cosine x. Is that the same thing? Yes. So sine x over cosine x is tangent x. And what's 1 over cosine x? Secant x. And there's nothing wrong with this, but the way you will see it written the most of the time and the way I think it's better for you to remember it is to flip those around and make it secant x, tangent x. Well, she showed you this because we had to use it. I mean, we used this yesterday, but she wasn't showing you where it came from. So yeah, what did she say about it? Psst, psst, what's the answer, right? When you're not sure. So let's write this down first. Secant x, tangent x. So that, psst, right? P-S-S-T, where this is secant x, tangent x, and then you just ignore the P. So secant, the derivative of secant is secant tangent. The derivative of tangent is secant squared. Okay? Does that make sense? See how that works there? Now, what do we know about the derivative of all of the cofunctions? They're negative. Okay? So if you can get these two, yes, we could derive these. We're not going to. But this is definitely going to be, both of these are going to be negative because it has a even cosine is negative, right? Tangent goes with cotangent. And then so secant squared, this is cosecant squared. And then this is secant x, tangent x, so this is cosecant x, cotangent x. So what I've been told, and, you know, she's taught this for 12 years. She's graded the tests for 6 years or scored that's super important. So she knows, I mean, and they're always released, but I think she looks at it a little bit more in depth, that these don't show up that much, but these and sine and cosine will show up a lot. So do you need to know these? Absolutely. Just know how they're related to these, but these and sine and cosine will come up a lot. Okay? Everybody okay so far? But you'll just know them. We'll use them a lot. You'll know them. All right. What do I want to do next? Since we don't have tons of time. We're going to skip this next one for now. We'll come back to that like Monday or something, but let's move on to this one. All right. So it says, oh, I only gave you that one. I'm sorry. I didn't want to put it all on your table because then when you have all these papers, you don't know what's what. So many. I am. Would you rather me make it all digital where you had to write on a computer? No. Okay, so we are going to find, and we did some of these kind of yesterday. So sometimes we're given the values of a function and its derivative or graph of a function to help us evaluate. So we're given this function. We want to find f prime of 2. We have g, g prime, h, h prime. But if I need to find f prime of 2, what do you think I actually need? F prime. Well, yeah, I need f. I have f. So then I need f prime, right? So we're going to do f prime of x equals, and see, here's a good reason why you don't want to know it in terms of f and g. It's the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator. All over the denominator squared. So I have f prime of x. I want f prime of 2. So that's going to be g prime of 2 times h of 2 minus g of 2 times h prime of 2 all over h of 2 squared. squared. Does that h of 2 squared become h of 4? No, don't do something ridiculous like that. Okay, am I at a safe stop? No. I substituted something in, but did I actually evaluate yet? The answer to that is no. So now, when I actually evaluate, so f prime of 2 is equal to, and your first step should always just be substitute it in. Don't try and do any math, even when it's easy. So what is g prime of 2? Negative 4. So I have negative 4 times h of 2 is negative 1 minus g of 2, which is 3, times h prime of 2, which is 5, all over h of 2, negative 1 squared. This right here would be a safe stop. But if it's multiple choice, that could be an answer, but it might not be. And if it isn't, you have to be able to do your arithmetic here, right? So f prime of 2, the actual, putting next, 2. So the denominator squared is just 1, so I don't really even have a denominator, right? So this would be negative 4 minus 15. No, something's wrong somewhere. What did I do wrong? It is negative 4 right here. Told y'all. Okay, I blame y'all. You're supposed to make sure your teacher knows what they're doing. Okay, 11. And then, so then this would be like your multiple choice answer. Okay. Oh my gosh. Yes. Just wanted to see if you were paying attention. Thank you, Adriana. You're paying attention. I know, y'all never believe me when I say that. I even looked back at my paper that I do have negative 11 on it. All right, let's look at this next one. So the graph of function f is shown. Now you have to pay really close attention. The more and more graphs we get, it is the graph of f, but we're talking about g. So that happens a lot. If we have a graph of f, we're probably not really given stuff about f. So you got to make sure you know what's what here. I want g prime of 2. All right? So I need, first of all, then I need g prime, right? So g prime of x from this. I'm going to take the derivative of the numerator. What's the derivative of the numerator? What's the derivative of f? F prime, right? So f prime of x. What's the derivative of negative 1? 0. So I'd have minus 0, so I'm not going to put that. Make sense? Times the denominator, which is x squared, minus the numerator, which is f of x minus 1, times the derivative of the denominator, which is 2x, all over x squared squared. Okay? Everybody okay with that? All right. So I need to find a couple of things. I need to know what g of prime of 2 is, but all this asks me for f and f prime. So when I substitute this in, g prime of 2 is going to equal f prime of 2 times 2 squared minus f of 2 minus 1 times 2 times 2 all over 2 squared squared. This would be a safe stop. Oh, no, it would not. Why would it not be a safe stop? Because I haven't evaluated, haven't actually done the f prime. So I have to go find those, right? So I need f of 2 and I need f prime of 2. Where do I get f of 2 from? Straight from the graph. When x is 2, f is 3. Now I also get f prime from the graph, but from what do I have to look at for the primes? Slope. So at 2, I need the slope of my graph, which these happen to be parts of lines, which is nice, and it is 4. So when I look at places where I can start, I go up 4 and over 1, so it is 4. Now, g prime of 2, try again. F prime of 2 is 4 times 4 minus then f of 2 is 3, right? And I subtract 1, so that is 2 times 4 over 4 squared, which you could go ahead and make that 16, but I was just, for myself, trying not to do too much at once, because then I'm afraid this would be a safe stop, because I actually evaluated everything. And then when I do this, this is going to be 16 minus 8 over 16, which is 8 over 16, which is 1/2. That is not the answer. What did I do? It should be 3 times 4. Where did I get 4 from? Oh, shoot. Look, f prime of 2 is 4. Well, that's what I put. But f of 2 is 3. Maybe. I think I did it wrong on my paper. Dang it. No, I checked myself. It should be 4 times 3. Why is it 4 times 3? But this right here, according to Miss Bruce even, f of 2 is 3, f prime of 2 is 4. Oh. She messed up. You know what? I'm going to. Poor thing. Because, she's got some, I spike her anxiety. I know, poor thing. But on her notes, because I work through this stuff and then I double check myself with her for my notation and stuff. But up here, I probably shouldn't tell you all this because she was mortified. On her notes right here, she had a plus sign. She did all of the work correctly, but this was a plus sign. And so that always makes me second guess everything. Like, I thought I knew what I was doing as soon as I saw that. And so I asked her, I was like, hey, this was just a mistake, right? I was just confirming. And she was like, oh my God, she was covering it up and she started, oh my God, no, I mess up all the time too. Like, it's fine. I just want to make sure I wasn't like missing something. I don't know. So yeah, I don't know if I want to point something else out to her. She may never come back. I should. Hey, my class was to talk to you. You messed up. All right. Okay, we're going to stop there for today. We are going to come back and finish that. I want to do a few more with you, but what I do want to give you is I'm going to give you the assignment. I want you to work through at least a couple of these. Let me see if there's any. I feel like you have the skills to do all of this. Yeah. And I may not work through everything else that's on there because I have another page too, but I'm going to kind of pick and choose. Y'all look over the notes on the ones we haven't done and maybe circle some that you're like, this one looks like I might need to see it. Okay? Don't just put this in your binder and not look at it again before Monday. Okay? Be good. It's homecoming. I know. Well, I don't know. My brain's not working right now, so